Hi, everyone. Welcome back to day number 3 of our Kaggle Generative AI intensive course, where we'll be discussing generative AI agents. I hope everybody had great fun in the last couple of days where we were talking about foundational models, prompt engineering, and then also embeddings and vector databases. Today, we have a really exciting course for you, walking through some really interesting code labs where you can create your own agent, as well as getting Q&A with some of our really exciting guest speakers, including folks from the Ada team, which is baking AI assistive features into tools like Colab, as well as the creator of Notebook LM. So really excited to have you here today and to have you tuned in. As a reminder, as a course overview, the course that we're delivering is a 5-day generative AI intensive course on sort of all of the tools that you can use to build models, to interact with models, and to bake AI into your applications, sponsored by Google and Kaggle. You're getting daily assignments in the forms of white papers and podcasts, which explain the what and how of how things work, as well as accompanying code labs that will teach you how to do all of the great things that our speakers and our white papers are describing. You can test them out in Kaggle as Kaggle kernels, or you can export the notebooks and use them in Colab and run them at your leisure. This is really intended to help you dive deep and to learn some of the fundamental concepts around tech and around generative AI. So as a reminder, today is day number 3, where you have hopefully read all of the white papers, interacted with all of the folks on our Discord channels, and also listened to the podcasts. Coming up soon, we're going to have Anant walk through the code labs, just in case you have any questions, or if you wanted to have somebody kind of hold your hand as you tackle the great programming concepts. And we're really hoping that by the end of this course, you'll be building your own AI agents and using them to accomplish really interesting tasks. So with that, I'm going to turn it over to Anant for the curriculum review, and then also our code labs for generative AI agents. Anant, do you want to take it over? You might need to come off mute.
Yes, so thanks, Paige.
Awesome.
And before I start, I'd like to give a shout out to Mark McDonald, who helped create these collabs. And thanks for being here, everyone, and welcome to a live stream. So today I'll be walking you through the contents of the collab for day 3 AI agents, generative AI agents to be more specific. And so in day 2 and day 1, you've seen basically how foundational models are created, the fundamental components, how they can be made fast and efficient at inference time, as well as some of the applications and how they can be prompted and the various strategies for prompting large language models. And then you've also seen embeddings, how embeddings represent various different data types in compact semantic representations, which can then be combined together with vector databases and approximate nearest neighbor algorithms to kind of query and manage these embeddings at scale to build many generative AI applications, such as retrieval augmented generation, but also help with other applications such as clustering, classification, and so on and so forth. Now, building from day 1 and day 2, we come on to a topic which is very important, which utilize these techniques, both LLMs and embeddings and data stores, vector data stores, to build AI agents. And that would be the focus of this curriculum overview and code lab overview. So I hope all of you have had a chance to go through the white paper, or at least the podcast summary of it. So in the first section of the white paper, we explored basically the foundational components of what constitutes an AI agent, specifically a generative AI agent, and the various components being models, tools, and orchestration layers, and how these elements interact to enable intelligent behavior. We can then compile these components to build systems that are capable of understanding the world, making decisions, and acting upon those decisions, extending beyond the limitations of just standalone LLMs. Then the second part of the white paper dives into some of the tools that these agents can leverage to interact with the external world and access information beyond their initial training data. Some of these tools that we discussed are called extensions, functions, and data stores. Extensions being basically the bridge, which kind of connects the agents with external APIs, basically facilitating seamless execution of these API calls. Then functions. Functions are basically the tools which empower developers with fine-grained control over their data flow and system execution, basically enabling client-side processing and data transformations. Then data stores. And data stores provide agents with access to structured or unstructured data, enabling data-driven applications and and other downstream tasks such as retrieval augmented generation. Now, in the next part, we then, after seeing these various types of tools, we then looked at how we can enhance model performance for agents using targeted learning approaches. Some of these being in-context learning, retrieval-based in-context learning, as well as fine-tuning to enhance an agent's ability to choose the right tools and then use those tools to generate the optimal outputs for the task at hand. These approaches basically equip agents with the specific knowledge and adaptability needed to excel in real-world scenarios. Then after all of this, the white paper concludes by looking at building agentic applications using LangChain and Google's Vertex AI platform, which greatly simplifies the development and deployment of these production-grade agentic applications and allow developers to refine the applications in an iterative fashion, and by providing the services which manage the complexities of infrastructure deployment and maintenance. So hopefully this gives an overview for those of you who are joining for the first time or who have read the white paper and want some background before our code lab. And now I'll be going into our code lab and I'll be taking over the screen. So, our first collab, which you got in your assignment today, deals with function calling with the Gemini API. Essentially, this collab goes over how you can leverage Gemini's automatic function calling to build kind of like a conversational chat interface with a database. In this case, for demo and learning purposes, we will be leveraging a local database, a SQLite in-memory database. But of course, in the real production-grade applications, you would be leveraging different ones. And it's important to note this is a toy example, so don't go just using exactly the same code in the production-grade applications, as you would need a bunch of safety and security constraints as well as other things on top if you would like to build a safe production-grade application. So we start off this collab with, as usual, like installing the necessary libraries, retrieving the Google AI Studio API key through Kaggle secrets, which we have done in the first couple of days as well, initializing the Gemini API with that API key, and the usual stuff. Then in this part of the collab, we create a local SQLite database, as I mentioned earlier, and populate it with some synthetic data, so we have something to play around with in order to learn how it works. So in this case, we create a synthetic table which contains product ID, product name, and price. These are the products which will be used, which the users can order. And then we create a staff table. This contains information about the staff members who would be kind of selling or taking orders from the customer, containing information like their IDs and first and last names. And then we create finally an orders table, which contains the order ID, customer name, staff ID, and product ID, basically allowing a customer to place an order with a particular staff member. And this is what it allows you to. Then we add some synthetic data into the products table. Similarly, add synthetic staff information and order information. So basically, that means this particular customer ordered a certain product with a certain staff member, and that is what we add into the orders table. Great. Now, at this point, we have a synthetic SQLite. Well, we have a SQLite database populated with synthetic information, and now we shall go ahead and define some database functions, which will basically be exposed as tools to the LLM in order to allow it to use these tools to interact with the database. Now, it's important to note that we'll be using an it's important to note that we'll be using a toy example here, but it's important for the LLM in order to let an LLM understand which functions or which tools to call and how to convert these functions, like how to convert the natural language text that the user is sending, how to convert it to a query and the parameters for the queries and the function parameters. It's important that you need to often need to define what each parameter stands for, what does it mean, the input parameters, and how the output can be processed. So the LLM is able to take natural language queries from users and able to determine which function to call. Hence the name of this Colab function calling, and is able to then take and formulate those parameters and extract the parameters from the user prompt and call them accordingly. So important that the LLM should be able to understand what the function is capable of accepting and how to use its output and what each parameter stands for. Now, we provide three key pieces of functionality here, three functions. One function is to list the tables in the database, then describing the table, as well as executing a query. By using these three functions, the chatbot or the interface can easily understand, okay, given this natural language query by the user, I need to see which table is the most relevant or which tables are the most relevant, then see what information the table contains, see the various columns in the table, etc. And then what do I need to get out of the table? What information do I need to execute against the table, the query? And this is the three interfaces we provide the large language model, and this allowing us to make this application possible. Now, so we define these three functions. One is to list all the tables to see what kind of tables we have in the database. And then we describe the describe table, which describe basically the table schema, such as like what kind of fields do we have in each of the tables. And then we provide an interface to the large language model by defining a function for executing SQL queries against that, against a given table. For example, an example statement could be select all from product table. Now that we have the synthetic table, multiple tables created in memory database, and we have the various interfaces and functions defined which can interact with these tables, it's now time to implement the function calls, and in this part of the Colab, we'll be directly allowing Gemini to make those function calls behind the scene and get the response and kind of look at what the user is asking for and use the information provided by the response to formulate a natural language response back to the user. However, given that these function calls interact with the database and LLMs are not perfect, they can hallucinate. So it's in a production grade application, you might want to put safety checks or even have the code for the queries checked manually by a human before they're executed. For this demo, we'll be letting the LLM execute the function calls and use the function responses automatically without any check in between. So we then define the instruction for our agent, which will be saying, okay, you're a help with chatbot. You have to answer the user's questions by using the three kind of tools, the database interaction tools, which are the three functions: list tables, describe tables, and execute query, to provide the answer back to the user. So we are initializing the model, providing it the tools here. And because for complex queries, it might require multiple tries. So we are adding a retry mechanism here as well. Now, everything is set up. So hope you're excited. So we ask the LLM, use all the tools at your disposal and tell us what is the cheapest product in our in our whole database. So you can see that the LLM first sees, okay, in order to figure out what's the cheapest product, let us look at the various tables that are present, and it finds a product table. It then asks it, it's okay, now that I have a product table, I need to know what's inside it. So it figures out, okay, I would need to, the agent figures out it needs to get the column information to see if there is a price column somewhere, and there is, as we defined earlier. And then it's okay. Then it executes a query against that table to get gets the cheapest product based on the price. And then we ask a follow-up question of how much is it, and then it has already access to the context because we're using the chat interface of the Gemini model, which keeps the history of the previous interactions. And if you remember from day one, the chat interface can kind of informs this query here. So it doesn't have to retrieve the table information. It directly executes a query against that table, which it already knows. So yeah, this kind of we can do it more so often in the Colab, and we can understand what kind of information is it looking at when it's defining when it's interacting with the various functions, and this part of the Colab kind of dives into more detail around this. Yeah. So in interest of time, since our next collab is quite large, I will dive into it in a bit more detail. I dived into this one in a bit more detail, but the next one I'll be skimming over some of the high-level components. So let's start right with it. Sorry. Yeah. So this collab talks about building an agent with LangGraph and the Gemini API, and it uses a lot of
Hey,
components.
Anant, I
Yes.
think we might still be seeing the first notebook. So if you're showing a second notebook, you might want to switch tabs.
Okay.
Yeah.
Okay. And give me a second. Yeah.
No worries.
So
I love function calling, though. I think it's one of the most underappreciated ways to interact with large language models. So love that you walked through that example.
yeah, perfect. Thank you. Yes, so I mean, the function calling is not all. In this notebook, we go through, we use an open source library called LangGraph to go over how to build a complete application with back and forth interactions and so on and so forth. However, this collab is quite detailed, and in the interest of not extending our live stream too much, I'll be covering the high-level concepts behind it. And you can always go into the collab at your own convenience, those of you who are listening to this live stream, and pry in more detail on how it works. So let's get started. So the key concepts to understand this notebook and is the LangGraph uses a graph structure. And a graph structure is basically consists of nodes and edges. And a node basically represents an action or step to be taken. Kind of like when a human interacts with an AI chatbot, there is you switch over from humans to chatbot. Like it's like a turn system where you kind of the human starts and the chatbot answers, etc. And node is the action, like human response, chatbot response, function calling. These are all actions, and the edge represents the transition. For example, whenever the transition, the chatbot answers the human or the user, then it's the user's turn to kind of answer back. Then these are all transitions which are represented by edges. it's a bit more detailed, so I would recommend looking into the LangGraph documentation to understand this concept in a bit more detail. Now, in the first part of the collab, we define the core instructions which allow at each step it provides all the information to the chatbot to understand what is the current situation, what has been said, what are the messages that have been exchanged, what is the order, because we're talking about a barista chatbot here, where you'll be kind of interacting with the barista bot, which can place orders for you, get information, etc. So to see what the status of the customer's order is, and if whether or not the order is completed. So it needs that information at each step in order to kind of inform itself on how to interact and which functions to call and tools to invoke. So that's what this initial setup is about, to provide it an interface through which it can keep track. And then we define the instructions for the barista bot, allowing it various options like clearing orders, taking orders, placing orders, etc. Then in the first part of the collab, we talk about a single turn chatbot, right? We just see, okay, with a single interaction with the user, how can we like add the nodes and the edges required to interact, like a single turn interaction with the user, where the chatbot introduces itself and the user asks it something, and that's it. And we can see that it starts in the this chatbot, it directly transitions to a chatbot. And later on in the second part of this, we see that it takes a single human message and the chatbot answers. Now, this is all stuff which is pretty simple to understand. Where it gets a bit more tricky and very powerful at the same time is when you want to have an almost indefinite interaction between the human and the chatbot until a terminal state is achieved. Like, let's say in this case, if you remember earlier, we defined a finished function where we know that the order is confirmed and placed. That's when we want the interaction to end. And this is what we do in the third part of the collab, where we kind of define, we go over the necessary structure to define a to and fro chat between a human and a chatbot. Now this can be, of course, troublesome, especially if you have you need a way to terminate the conversation. So we add a conditional edge, which provides it an interface to terminate the conversation if the user like kind of has finished placing an order. And you can see here in the graph, like we have this graph showing that a chatbot can interact with a human and back and forth until a human decides to terminate the interaction, and then it kind of ends the application. So I'm going over it at a high level because there's a lot of things to cover. But basically, the rest of the collab is quite big. But the idea is that it just adds function calling to the loop. Till now, it was just text interactions with the model. But you can also, of course, provide various functions, like we looked in the first collab, define various tools and allow it to get menu information from dynamic or static sources, allow it to kind of place the orders here through various tools, get the current order information, and much more. Now, in the interest of time, I'll be closing this collab overview with one last statement and one last diagram, actually. So towards the end of the collab, you see that step by step, we have iteratively built up a system where a chatbot is interacting with humans, like taking orders, retrieving, providing the humans the necessary information, as well as whenever necessary, it's invoking various tools and also doing function calling behind the scenes in order to kind of complete this application. And both the human and the chatbot are able to then terminate the application. So this is what this collab is about. I would recommend going through it more detail to get more information about this and play around. There's a lot more in store. Thank you.
Awesome. Thank you so much for giving that great overview over function calling and LangGraph and how you can kind of orchestrate models with things like retrieval actions or looking up tables in a database or adding things to a database. As I mentioned, I think this is one of the most underexplored and sort of high impact, high ROI things that you can do with large language models. And it's really, really cool to see all of it kind of laid out for people to learn and to understand in these collab notebooks. Thank you again to Mark McDonald for creating them and for making sure that they're incorporated into this Kaggle course. Now I'm going to go back to our slide deck. And it looks like up next we have our Q&A. So I am so excited to welcome all of our great subject matter experts here today. But before I do that, I want to give a quick shout out and thank you to all of our wonderful moderators on the Discord channel who are answering questions tirelessly around the clock, around the world. The sun never really sets on generative AI at Google. So thank you to Polong, Kaz, Mark, Eric, Erwin, and Miles for kind of stepping in and for helping debug things in real time. And also make sure to add your own questions to the Discord channel so that we can get our guest speakers for tomorrow to answer those items for you as well. Today, I'd like to, I am honored and really excited to welcome our expert host, Stephen Johnson, who is the creator of Notebook LM, Wes Dyer, who's the engineering lead for our Ada team, which is focused on AI, kind of AI developer assistance and more for many of our Google products. Julia, Alan, and Patrick, who are kind of leading the charge for developing AI features related to agents and function calling on Google Cloud. And we have a great list of questions in store for you as well. So first off, Stephen, welcome to the Generative AI Intensive course. We're really excited to have you here. And also congratulations on winning, I believe it's one of Time's Products of the Year for Notebook LM. Is that correct?
Yes, one of Time's inventions of the year. We were very
Awesome.
excited. We did that just happened a couple of weeks ago, so that's been really fun.
Excellent. And you are also at TED AI San Francisco, I believe, as one of the guest speakers, kind of articulating some of the ways that Notebook LM has been impactful and kind of driving change in the generative AI space. I love how it's created kind of a new paradigm that isn't just the regular old chatbot paradigm for people to interact with these models.
Yeah, that's part of the vision from the very start. I mean, we've been working on what became Notebook LM for more than 2 years now, and
Yeah.
the idea was like, what would happen if you started from scratch to build a tool for thinking and organizing your ideas and organizing your research and potentially writing, if you knew from the beginning that there was going to be a state-of-the-art language model at the center of the product, like not adding it to an existing product, but like start from scratch with the idea the whole thing's going to be built around this incredible new technology, and so that's what we ended up building, and we kind of the way we've kind of come to describe it is it's basically a tool for understanding things.
Yeah.
And everything in the product is designed to help you understand complex material, organize ideas, extract insights, see patterns. And from the beginning, it was predicated on the idea of what we call source grounding, which is sometimes called RAG. In the industry, we think source grounding is a nicer term for it. But it means that you upload the sources, the information, the documents that you need to do your work. And then from that point on, all your interactions with the model are grounded in the information in those documents. And so we go through and we have things like inline citations. So when you get an answer from the model, you see all those answers have little kind of footnotes, and you can click directly on those footnotes and see the original passage in your sources that the model used to come up with that answer, which means that you can fact check, you can dive deeper and read the original source material. It's just a really great way to navigate through information that was just not possible before. And all of this is dependent on this incredible model of Gemini Pro 1.5, both the ability to have that long context where we can put all your documents in the context window of the model, and also things like citations, which Gemini does kind of natively.
Awesome. I love being able to understand like very discreetly how longer context can really enable these features for creators. And I know many folks, many of the kind of developers that I've talked to have mentioned that they get frustrated sometimes where it can be really challenging to figure out if a large language model is hallucinating something or if it's actually referring back to content. So having those citations baked in is really compelling. Um, Excellent. So tell me also a little bit about what has been your favorite use case for Notebook LM that you've seen, either within Google or outside of Google.
Yeah, I mean, the thing that has been amazing for me personally is I have a single notebook where I have collected as sources 8,000 quotes from books that I've read over the years and articles that I've read over the years that have been kind of part of my research and things like that. And plus, I write books in my non-Google life, and so I also have the text of a lot of the books that I've written in a single notebook. So you can have like 25 million words worth of sources in a single notebook. And so when I go to this notebook that has all these quotes and has all this material that I've written, I can just, kind of riff on ideas or ask questions. And the notebook, the AI that's in that notebook basically has an incredible expertise in the history of my thinking. Like 20 years of my thinking is kind of active in that notebook. And so whenever I'm like wrestling with a new idea, I go to that notebook and I'm like, hey, what do you think of this? Any sparks, any connections? And it'll be like, oh yeah, you read a book about this like 7 years ago that you've totally forgotten, Stephen. And here's the excerpts from it, or here's what's relevant to it. So it feels like an extension of my brain in this way that is really powerful. So that's been really exciting. And then we can talk about, we released this new audio overviews feature that came out 2 months ago or so. And that's where you upload your sources and you generate a kind of remarkably lifelike podcast style conversation between two hosts. There's another version of this at Google called Illuminate, which is, I believe, what's being used to generate the podcasts for this course. And people are just loving that feature. And the craziest use case for that is that we've seen a lot of people do is you upload your resume and you generate an audio overview based on your resume. And the hosts are
Cool.
basically instructed to be engaging and enthusiastic about whatever you give them. And so it's a great way to feel good about yourself because you'll upload
Awesome.
your resume and they'll be like, wow, Stephen, you've really had a very busy year. You've accomplished so many things.
Excellent. I love having that personal hype
Yeah.
notebook to be celebrating all of the great successes. This is wonderful. And uh, the idea that you mentioned around having kind of like a thought partner that's basically you with perfect memory, like perfect recall for all of the different bits of information that you've experienced over the last years. That's super, super cool. And really, really excited to play more. If folks are interested in testing out Notebook LM, what is the URL that they should go to?
Notebooklm.google.com.
Excellent. Thank
Yeah.
you so much. And speaking of having kind of a personalized hyper expert sort of companion for doing work, Wes, I have been really, really enchanted with the AI features that you and your team have been baking into Colab. I use it literally every day, both for code generation as well as fixing errors and explaining errors. So thank you so much for your work, and then welcome also to the Kaggle Generative AI Intensive course.
Thank you. Yeah, we use it.
Yeah.
We use it every day too as we build out more
Yep.
developer features. Um, Colab
Excellent.
and data science agent is just been really a benefit for all of us. One thing to kind of note is that the data science agent for Colab that we announced back in May at I/O is just the latest in a string of AI kind of enhancements to Colab. And all
Yep.
of these things really kind of do the same thing, which is that they increase the velocity that all of us can move at when using AI tools and doing development in Colab and other places. With more velocity, of course, means we can experiment faster, try out more ideas. And we found, as we're doing our own kind of AI, ML, and data science work, that the primary determining factor about how much we can do and how much progress we make is with the velocity of the experimentation we can have. And so
Yep.
enhancing people's ability to have more velocity by giving them tools like the AI features is really kind of magnifies what they can do. And specifically for the data science agent, what we announced back in May was that is that you can kind of ask a question, give a data set, or even ask like a modeling question, and of the agent, it'll go off and do a multi-step process, including things like importing the data, exploring the data, cleaning the data, visualizing it, and ultimately ending up with answers to questions, as well as models, that kind of thing as the output. Then from there, you can iterate and kind of go on to do bigger and better things. We're continuing to enhance this and bring out new ways for people to interact with it.
Excellent. And I'm assuming behind the scenes, these agents are using tools like function calling, and all of the great the great features that we learned about during the course of this last lesson. Is that correct?
That is absolutely correct. We use function
Yep.
calling, use retrieval, all kinds of wonderful things like we've been talking about.
Excellent. That's perfect. And I am very, very excited to hear that more and more AI features are going to be coming to Colab. I know that it has increased my velocity personally, magnitudes over the course of the last 6 months. So excited to see the next features get released. And the next question would be for both Stephen and Wes. We already touched on this a little bit, but how are you thinking about function calling and retrieval in the systems that you're building? Are these techniques and tools that are being used? It sounds like they are for data science agents. Stephen, is retrieval getting used within NotebookLM? Is that one of the things that's kind of baked into the citations process or the data recalling process?
Yeah, I mean, it's a little bit above my technical pay grade to get into the details of this, but yes, we do. I mean, we do this kind of semantic retrieval. That's an important part of the process, particularly if you have a large set of sources that exceed the amount of information that can fit in the model's context. And so we've built some quite smart tools for kind of getting the most relevant passages from your sources, and then putting them in front of the model with the custom prompt that we have. And so that's been something that was literally like the first feature we had back in the day. It was just in a collab basically in August of 2022. You could give it some source material and ask some questions, but the source material could be like a page long instead of 25 million words. So we made a little bit of progress.
Amazing. I love that the kind of fundamental Lego brick building blocks that folks are learning this week are the same tools and techniques that folks are using to build the products at Google and then also external to Google. This is very exciting. Thank you both for the great discussion and for building the products that y'all are sharing. We'll have links in the YouTube video as well for folks if they want to go and try out NotebookLM and then also try out the AI assistive features in Colab. Next question. This is for Patrick and Julia. Have you seen any major changes to agent compositions in production since you started writing the white paper? And thank you also for authoring the white papers that folks have been reading over the course of this last day. What's changed, what stayed the same, and then what are the challenges and opportunities you see, kind of the new exciting things coming down the road?
Yeah, for sure. I'll start off on that one. So, thanks for having us today. It's interesting, Julie and I have been thinking about agents for a really, really long time, way before the Gen AI, kind of craze took foot in the world. Julia was working on things like cognitive architectures and trying to, do research on that and understand how could we implement these things in production. And I was also working on sort of like the precursor to generative AI agents and just the conversational AI space and natural language processing and stuff like that. So when we started writing this paper, it's really hard to predict the future in this space and know like what's going to come in the next 3 months or 6 months, because in the Gen AI space, that's kind of like an eternity, right? So as we thought about, putting, words to paper and thinking about what are the ways that people will start kind of architecting these agents in the future, we thought really carefully about like, what are the composition of agents going to look like? What's going to happen a month from now? What's going to happen 6 months from now? Things like that. And so I think the things that have stayed the same roughly are the architectures. We see that, agents have models, agents at the foundation, they have tools that they have access to, and then these, kind of orchestration layers, runtimes, memory, goals, to try to achieve these particular things. So a lot of that has really stayed the same, and I think we're happy to see that the paper has aged well as we've kind of written it, and as things have grown over time. The things that have really changed, I think, are the fact that the models themselves are just simply getting better and better over time. When we first started writing the paper, we had some really early LLMs, and they were okay-ish, but it ended up, you had to put a lot more into your reasoning layer and your logic layer to kind of control the things that you wanted your model to do. But with some of the latest models that are coming out, it really just makes the orchestration layer so much more simple. A lot of these models are baked in with much better tool calling, much better logic and reasoning, abilities to do chain of thought natively, abilities to do code execution natively. And so all of that is really just making sort of like the higher level abstractions of building these agent frameworks even easier and easier over time. So I don't know, Julia, if you want to add anything to that.
Yeah, absolutely. So big +1 to everything that, Patrick has said. We've really been thinking about this for a while. And I'm loving hearing all the shout outs to function calling and to tool use today, because that's, been something I've been thinking about for quite a long time. So really excited also to see what folks start to build with the contents of this course. And I think that's a little bit what I'd love to focus on here on the challenges and opportunities side that we see. I think there's still so much that can happen here in this space. Right now, we still see, I would call them fairly simple implementations, often with RAG, with a handful of APIs, things like that. And what I'm starting to see and what I'm really excited about is the ability to solve kind of complex real world problems with lots of different APIs, with mutating actions, with running different simulations, et cetera. And I think there's just so many industries that this can apply to, and also that it goes far beyond the realm of just chat implementations per se. And there's so much more that you can start to do with these things. If you think about industries like supply chain or security or kind of other spaces that that really have kind of background processes that can also work and automate. And when you hear things like what Notebook LM is thinking about, also going outside of that kind of frame and interaction.
Awesome. Thank you both so much, and thank you for the great work that you've been doing to build robust function calling and tools use into the Vertex AI Gemini APIs. I know we've also been drawing on some of those learnings for the Gemini developer APIs. So thank you for making it real. And Julia, has anyone, speaking of specialized domains and specialized kind of versions of function calling and tools use, has anyone implemented an agent focused on security? And where can I find overall guidance on implementing agents for cybersecurity?
That's a great question. And as I just mentioned, the security industry is a space where there's a lot of opportunities for agents. I mean, just think about things like threat classification, tracking, et cetera. And I really think that a lot of this is just at the beginning. So as far as I know, we'll actually be talking about SecLM tomorrow. So look forward to tomorrow's sessions where we'll look into, I think, a semi-agentic setup that can address some of those security challenges using LLMs. So more to come on that front.
Excellent. Excited to have the discussion tomorrow. And also, is there a way to evaluate the accuracy of the tools that Gemini selects? If there are deviations whenever Gemini selects a tool, are there any ways to remediate? And I've run into this at least a couple of times where when I specify different functions or different tools to call, sometimes multiple tools might be applicable to the same problem. How can you start thinking about doing a kind of composite tool selection or just getting additional information from the user before selecting a tool?
Yeah, absolutely. And I absolutely love this question and it's something that Patrick and I spent a lot of time thinking about also as we wrote the paper. I think there's an entire follow-up section to do on kind of evaluation and taking these things from kind of testing to kind of production and iterating on each of these tools. From that perspective, right now, I'd love to kind of just do a quick shout out to actually some of the Vertex AI tooling that we have around evaluation. So anybody that's working kind of with function calling, you can actually check out the Gen AI evaluation service, and using kind of your prototype, you can upload data and actually test kind of and evaluate outcomes to kind of get a sense of the accuracy and those kind of things ahead of time, and start to see how you can kind of fiddle with the different knobs and dials in order to kind of make these things more accurate. So I think folks will follow up with a link on that front. With regards to function calling now, like specifically, I think that there are a couple things that are pretty generic to Gen AI as a whole. You want to log and analyze kind of tool selection decisions over time. So you want to track Gemini's choices for tools, their user queries, and then understand kind of the rationale and the patterns behind those things, so that you can start to work and improve those kind of potential errors. And then at the same time, that ties directly into developing kind of those test cases with a diverse set of queries. So as with any Gen AI product, you really want to kind of get those use cases, get those testers, get those people that are starting to use whatever you're building, so you can see how they're using it, and collect where Gemini is also failing, or where there's kind of issues with the tool call, so that you can then use those things to over time do things like refine the prompt engineering. We've had all different kinds of examples where you have to be really careful with the wording that you use in the prompt that you're putting inside, right? We've seen examples where essentially, without meaning to, we actually told the model not to use functions, and so we just have to be really, really careful, and by like collecting those examples, we can then actually look for those patterns and look to understand kind of what the model is doing. Secondly, we can obviously work on expanding and continuing to improve the tool definitions, so ensuring that they're really unambiguous, and actually often using the model to help you do these things is really useful. And over time, you can also, as you especially think about getting to production, you can also think about things like doing targeted learning, where you're kind of fine-tuning Gemini, or really giving it a RAG-based query on a tool example ahead of time, so that it knows a bit better as to what it should be doing in this case. So I think there's definitely some opportunities there, and it's going to continue to kind of improve as the models also continue to improve.
Yeah, I love that, and I really do feel like you can get a lot of alpha just by investing a lot in prompt engineering, at least today, and helping using Gemini or using other models to help build the prompt to have more robust systems. If folks are interested in open source options for evaluations as well, I've been really loving using PromptFoo, which is an open source evaluations option that supports both text, code, and multimodal based evaluation. So we'll have the link for that in the chat as well. Excellent. And then, yep.
Sorry, Paige. I just wanted to jump in real
Yep.
quick and add a comment about evaluations. If
Yep.
people are watching this and you're curious more about evaluations, we're going to be covering this on day 5 in our ML Ops section of this same course.
Awesome.
So join us in a couple of days, and we'll touch more on evaluations as well.
Excellent. And moving just a little bit, because one of the fun things about Google offices is that to conserve energy, if you don't move enough, the lights go off in the back of the office. So if you see me moving around, that is why. Excellent. Thank you for calling it out, and get excited for day number 5, where we'll be discussing evaluations in more depth. And then next question, in building an agentic RAG system for better responses, there are a lot of intermediate steps between the user query and getting a response from the large language model. How can we deal with that latency? Patrick and Alan, do you want to take this one?
Sure. Yeah. I mean, I think that don't forget about traditional application development best practices. You can invest in pre-processing, improving the quality of the data, improving the chunking mechanisms or whatever the details are for your data, and then improving the quality and performance of the search, right? Because RAG or grounding is really all about getting the right facts or chunks into the context window of the prompt. So you can invest a lot in the system. When you're going to agentic RAG, you're basically adding more and more steps. Perhaps reducing those steps through that investment is sort of standard application best practices. Additionally, you can do tricks like execute multiple queries in parallel, and you can evaluate the responses of those parallel queries and pick the most relevant answers. There's some other stuff. Patrick, we've talked about this a bunch. Do you want to jump in?
Yeah, I think just to add to this, from a developer perspective, there's always this propensity to want to use the coolest, fanciest, kind of code or implementations out there. But a lot of times, going back to kind of just basic system design principles and thinking about simplicity is really the right way to go. And I know generative AI right now is super cool, and agents are cool, and RAG is cool. But sometimes just doing, retrieval from a cache and responding with that answer is the best outcome, because you have to remember that when you're building these systems for production, what really matters is the outcome, right? Like the results that you're trying to achieve. It doesn't matter that you implemented the coolest, most agentic system behind the scenes. What matters is the outcome to the users of that system. And so kind of keep those things in mind as you're doing this, traditional system design thinking around how you should be implementing this for your customers, your partners, or for yourself.
Can I do one more quick plug? You mentioned cache. A lot of people are talking about caching the final output, and that's awesome, right? Context cache is an unsung hero. A lot of people are not experimenting with that enough. Go check out long context window and context cache. You can get a lot of stuff done, especially for small use cases or early prototypes. There's a lot of opportunity in those features.
And then we cover context caching as well as some of the optimization steps for retrieval and making LLMs faster in our day 1 and 2. So go read those white papers to those of you listening for more information.
Excellent. And I love the call out as well to use whatever tool is most appropriate for the task, even if it isn't necessarily like the most bleeding edge generative AI tool. I've often been using function calling for calling smaller open source fine-tuned models to do specialized things like image segmentation or kind of more dedicated tasks. And given that they're much smaller models, they're located on device. They can get much faster results than if you were using a much more powerful model, and also often for cheaper. So function calling it has been a really nice win for helping right size calls to the right tools. Awesome.
Paige, maybe just one quick throw in there. We've also seen it with calling like time series forecasting models, which gets really, really interesting when you can get kind of a time series forecast into kind of whatever system you're starting to use and things like that. So
very
totally
cool.
big +1 on that front.
Excellent. Very cool. And so last question before we get into our pop quiz. This is for Alan. When would you recommend using a minimal implementation like the Gemini API versus a stateful graph-based approach like using LangGraph, which is an open source library that we were using in the Code Lab?
Sure. This is sort of what we were talking about before. These are just design principles, right? Are you doing a quick prototype? Please just start quick. Like just get some ideas out there, play with the tools, learn the tools, see what's capable, see if your use case works out. The lowest number of dependencies, just get in there and play. But it is difficult to control agentic systems. And especially as the complexity grows, your level of effort to control that system grows. So I think maybe day 1, just use the SDK, play around, and get going. Probably day 2, get invested in some kind of a system to control that behavior. I do like LangGraph or graph-based representations. It's not the only one. There's lots of other frameworks out there that use graph-based representations. Breadboard is a great one that uses graph as config as opposed to graph implemented in code. Both of these are just means of understanding what the agent is capable of doing. That's like introspection, what might happen, and observability. What did the agent do? What choices, what steps did it make, etc. These are really tools to help you as a developer understand what's happening and control what's happening. That's all it is. So these are techniques that have been created to help you as a developer better understand the system that you're building and better control it. That's it. So I do think play around first. You don't have to invest in the system. But adopting a system on day 2 is probably a good plan, because by day 20, you will wish that you had done so.
Yep. Excellent. And there are many great open source libraries being created to help with precisely these problems. Things like Crew AI and Agent Ops and LangGraph.
And
I think they're GenKit. Yep, lots and lots of things to help bring reason to the chaos. So excited to see even more of these get built out and become more robust over time. Awesome. Thank you all so much for our experts, for giving your time, for your insights, and then also for writing all of the great curriculum and white papers that we've been learning from these past days. Really appreciate you and your time. And thank you again. This has been fantastic. And now, without further ado, we are going into the pop quiz. So everyone get pens, pencils, papers, something to write down your answers on, and we will have 6 questions today. I will go ahead and get started with the first. What is a generative agent? Is it A, a type of machine learning model, B, an application that can observe the world and act upon it using tools, C, an LLM that can only be used for text generation, or D, a kind of hardware for training large language models? Hopefully everybody was reading the material and can and pick out the right answer pretty quickly, but I'm going to give you 5, 4, 3, 2, 1. Hopefully everybody picked B, an application that can observe the world and act upon it using tools and function calling. Question number 2, what is the primary function of the orchestration layer in a generative AI agent? Is it A, to generate creative text and images, B, to manage the agent's internal reasoning and planning process, C, to interact with users through a conversational interface, or D, to store and retrieve data from external sources? Hopefully everybody was paying attention in the white papers. I believe this might have also been mentioned in some of our code labs, but I'm going to give you 5, 4, 3, 2, 1. Hopefully everybody picked B, a way to manage the agent's internal reasoning and planning process. Number 3, in what scenario might a developer choose to use functions over extensions in a generative AI agent? Is it A, when the agent needs to make multiple API calls in a sequence, B, when the API requires real-time interaction with the agent, C, when the developer needs more control over the data flow and API execution, or D, when the API is easily accessible by the agent's infrastructure? Hopefully everybody was paying attention in the white papers. Make sure to jot down your answer. And it is C, when the developer needs more control over the data flow and API execution. Question number 4, we're halfway there. What is the purpose of data stores in a generative AI agent? Is it A, to store the agent's configuration settings and parameters, B, to provide the agent with access to dynamic and up-to-date information, C, to execute complex calculations and data transformations, or D, to monitor and evaluate the agent's performance over time? I'm going to give you 5, 4, 3, 2, 1, and it is B, to provide the agent with access to dynamic and up-to-date information. You know, we were discussing that quite a bit yesterday and also today. All of these retrieval processes are very, very important for making sure the agents get the right answers, and also that our machine learning systems are equipped with the right data to give you the most up-to-date answers. Question number 5, which of the following is not a characteristic typically associated with generative AI agents? Is it A, they can create new content such as text, images, or music? B, they can learn from large data sets to identify patterns and generate similar content? C, they possess inherent consciousness and understanding of the content that they create? Or D, they can be used for tasks like translation, summarization, and content creation, which is not a characteristic typically associated with generative AI agents? 5, 4, 3, 2, 1. C. Agents do not possess inherent consciousness and understanding of the content they create. They are just acting on inputs and outputs, not in a conscious or self-deterministic way. And then last question, number 6, what is the mixture of agent experts approach in agent development? Is it A, combining multiple language models with a single agent? B, using a variety of tools to enhance agent capabilities? C, combining specialized agents, each excelling in a particular domain or task? Or D, integrating different reasoning frameworks within the orchestration layer? 5, 4, 3, 2, 1. The answer is C, combining specialized agents, each excelling in a particular domain or task. And you might have also heard of mixture of agent models, or mixture of expert models, rather, that are sort of doing similar sorts of things, that are baking together many different models, each a little bit better at particular domains or tasks. So hopefully everybody got 100% correct. If not, make sure to refer back to the white papers and the different assets that we were using throughout the week, so that you can learn and reflect. And I want to thank you everyone again for taking the time to learn today and with us over this 5-day adventure. Make sure to tune in tomorrow, where we'll be talking about domain-specific large language models and bringing on another great round of guest speakers, and learning a lot more about SecLM and some of the other domain-specific models that Julia was mentioning earlier. So thank you again, and we will see you tomorrow.